What specific problem does the new method or algorithm aim to solve?
The new method or algorithm aims to solve the problem of overfitting in large language models, LLMs, on benchmark datasets, specifically on grade school level math problems like GSM-8K. The goal is to address concerns that models may have weaker reasoning capabilities than believed due to potentially memorizing examples from the benchmark data. The new dataset, GSM-1K, is designed to mirror GSM-8K, but is created with human annotators to minimize data contamination. The study evaluates leading LLMs on GSM-1K and finds evidence of overfitting in some model families, such as Mistral and Phi, while frontier models show minimal signs of overfitting. The analysis also reveals a positive relationship between a model's likelihood of generating examples from GSM-8K and its performance gap between GSM-8K and GSM-1K, indicating potential data contamination as a contributing factor to overfitting.
How does the proposed method or algorithm work? Illustrate step by step.
The proposed method works by creating a new dataset called GSM-1K, consisting of 1250 grade school level math problems, to evaluate the reasoning abilities of large language models, LLMs. The process involves ensuring that GSM-1K mirrors the difficulty distribution of the existing benchmark, GSM-8K, through efforts described in the paper. The dataset is created solely by human annotators, without the use of LLMs or synthetic data sources to mitigate data contamination concerns. Leading open, source and closed source LLMs are then benchmarked on GSM-1K to assess their performance. The results indicate that many models are indeed contaminated by benchmark data, with some models performing up to 13% worse on GSM-1K compared to GSM-8K. Additionally, the analysis reveals evidence of overfitting in certain model families, such as Mistral and Phi, across various model versions and sizes. The study also finds a positive relationship between a model's probability of generating examples from GSM-8K and its performance gap between GSM-8K and GSM-1K, suggesting that models may have partially memorized examples from GSM-8K. Despite these findings, all frontier models and all sizes of the Llama 2 family show minimal signs of overfitting and are capable of generalizing to new mathematical grade school problems.
What are the theoretical or practical benefits of using this method?
The theoretical benefit of using the method described in the paper is that it allows for a comprehensive evaluation of large language models, LLMs, to assess their reasoning abilities accurately. By creating a new benchmark dataset, GSM-1K, specifically designed to mirror GSM-8K but with unique problems, the method helps in detecting potential overfitting of models to existing benchmarks. This approach provides insights into the extent of data contamination in LLMs, highlighting the importance of ensuring models can generalize to new problems rather than just memorizing answers from training data. Additionally, the method offers a way to measure the performance gap between models on different datasets, shedding light on the reasoning capabilities of various model families. Practically, this method enables researchers and developers to identify models that may be gaming existing benchmarks and prioritize models that demonstrate strong generalization abilities. It also encourages transparency in model evaluation by providing a framework for recurring evaluations and releasing evaluation code for reproducibility, contributing to the overall advancement of LLM research and development.
How is the method validated or tested?
The method is validated or tested through several layers of quality checks and comparisons. Firstly, the GSM-1K dataset was created with human annotators without the assistance of any language models or synthetic data sources to mitigate data contamination concerns. The dataset underwent 3 review layers to ensure correctness, grade school level math content, and proper formatting. Additionally, human crowd workers were presented with a set of questions from both GSM-8K and GSM-1K to identify the odd one out, with results showing minimal differences between the two datasets. Crowdworkers also solved problems from both datasets under time pressure, indicating that GSM-1K is comparable in difficulty, if not slightly easier, than GSM-8K. Furthermore, the method was validated by measuring the solve rates of models that were released before the publication of GSM-8K, showing minimal differences in performance between GSM-8K and GSM-1K. These rigorous quality checks and comparisons demonstrate the validity and reliability of the method used to evaluate the models on the GSM-1K dataset.
What results were achieved with this new method?
The new method achieved results that showed substantial evidence of many models being contaminated by benchmark data, with some models performing up to 13% worse on the newly created GSM-1K dataset compared to the established GSM-8K dataset. The analysis revealed consistent overfitting in several model families, particularly Mistral and Phi, across various model versions and sizes. There was a positive relationship found between a model's likelihood of generating examples from GSM-8K and its performance gap between GSM-8K and GSM-1K, indicating that data contamination was a significant factor contributing to overfitting. However, it was also discovered that frontier models displayed minimal signs of overfitting, suggesting strong generalization abilities, and even the most overfit models demonstrated the capability to reason and solve novel problems.
What are the limitations or drawbacks of the method?
The limitations or drawbacks of the method outlined in the paper include the potential for data contamination, despite efforts to prevent it. The study reveals that some models, particularly those from certain families like Mistral and Phi, consistently show signs of overfitting across various sizes and versions. This indicates that these models may have memorized examples from the benchmark dataset, impacting their performance on new problems. Additionally, the analysis suggests a positive relationship between a model's likelihood of generating data points from the benchmark dataset and its performance gap between the benchmark dataset and the newly created dataset, indicating potential data contamination as a contributing factor to overfitting. Furthermore, the study acknowledges that the interpretation of evaluation results can be subjective, and while the models may show signs of overfitting, they are still capable of reasoning and solving novel problems to some extent. Lastly, the study notes that the method used in the evaluation may not fully capture the complexities of model performance, as the reported results may not always align with individual model performance optimizations.